Hello all and welcome to the new video of BST. In this video, we're going to solve one problem, that is remove node from BST. Okay, we have to remove a node from BST. So let's just see how we can approach this problem and then we will code in the code editor. Okay, so here I have one BST. Okay, this is the BST and I have to remove a node. So there are different kinds of nodes present in this BST. First, let's just see what are different. Which has zero children. Okay, which has zero child. Second, which has left child. Third, right child. Right, and the fourth one, that is it has both the childs. So we have to solve our problem, that is remove for all of these conditions. Okay, now what is the approach for removing the node which has zero child? Suppose take one example, that is 12. Okay, that is 12. I have to remove 12. So I have to add nothing but I can just replace my value, replace with, I can say null. Simple. I will point and just saying that replace it with null. So then it will automatically be removed. So for the zero child, I will replace it with null. Okay, fine. Now, okay, replace it with null. Next, for the left child, for both of this, if the left child is present or the right child is present, I will just simply return that child. Okay, what I am saying it, suppose for example it contains the right child, so I can just say to its node, it contains the right child. See this, it contains the right child, right? So I can just say its parent to attach directly to it. Okay, to attach directly to it and simply remove this. Simply remove this. Now you can see my node is removed and it will directly attach with the node. Okay, with its child. So I can just say for this my problem is solved. Directly attach with its respective child. Right, now the problem comes for both child. Suppose for example I want to remove this one. Suppose it contains more elements, right? So I can take elements as 26, and for this I can take as 31. So we have these childs. Okay, we have these childs. Suppose I want to remove 37. Okay, I want to remove what? I want to remove 37. So what I have to do to remove? I'm saying calculate. I'm saying what? Calculate the left max of 37. Okay, what is the left max of the 37? 31, right? Calculate the left max of the 37. That means the maximum element in the left part. Okay, in this part, right? And make this value as this value. Make this as 31 and remove this. Remove this. Then my problem is solved. Why? See this. If I'm removing my left max, you can see that my 31 is greater than all of the element in the left part. That means it holds the BST property, and also 31, that is it is less than the right part. That means it also holds the BST property. That's why I have chosen what? That's why I have chosen the left max. So for this I can say, calculate left max, L max, then replace my node dot data with left max, replace my data with L max, then remove L max. Okay, so my all the conditions have successfully done. So I hope you understood the approach of this problem. Okay, fine. So we have seen the approach. Okay, so let's just write some code and see what we have got. Okay, now first the base case, that is if my node is null, return null. Okay, now I have to check whether my data is present on the left part or the right part. So I can say if my node dot data is less than data, then what we have to do, we have to call on what, we have to call on the right part, dot right with data, right? Else if my node dot data is greater than data, then I have to call on the left part, remove node dot left with data. Okay, else what, else I have found the data. Okay, I have found the data. So for what, we have say that 0 child, or I can say 1 child, or I can say 2 child. And in last we have to write the node part also, return node. Okay, so for the 0 child I have to check if node dot left is null and node dot right is also null, then I can return simply null. That's what I have written in the approach also. Now, 1 child, that means if it is left or the right child, I can say if node dot left is not null. Okay, I can say return node dot left, right? But where this value will be cached, we have not assigned the value. Okay, we have not cached the value, so I have to write it here. I have to catch this value. Okay, so for the right part I have to write that attach this with the right side, or I can say for the left I can say attach it with the left part. Okay, else if I have to write it here also, else if. Okay, else if my node dot right is not null. Okay, so what we have to do, return node dot right, right? Else I have 2 child. Okay, 0 child is finished, 1 child is finished, and now 2 childs. So I have to calculate what I have to do, I have to first calculate the left max, then I have to make data my as left max, and then remove the left max part. Why left max? Because it will honor the property of BST. Okay, so let's just say int left max is, suppose I have made one function. I will write the definition later, but I have made one function, node dot left. It will give me the left max. I can say node dot data equals to the left max. Okay, and then after that I can say remove what, node dot left from the left max, remove left max from node dot left, and attach, or I can say catch with the node dot left part. And what do we have to return? Return. Okay, so this is over. Now let's just write the max function, public static int max node. Okay, if my node dot right is null, return what, node dot data. That means that is my right, that is my max. Else return max node dot right. Why right? Because I know right contains the maximum element, the max element, which is greater than the root. Okay, that's why. Okay, fine, this is done, max is done. Now root is done, data 0 child. I've handled the case for the 1 child and for the 2 child. Okay, so let's just see, let's just submit it. Okay, it is accepted. Let's just submit it again. Okay, I have one test case failed. Why it is so? I can just check. Turn node.data. Okay, max as node.write. If I will write equals to null or equals to, then I have to return right here and left here. Let's just see if it is good. Yeah, it is a correct answer. Okay, so it is not taking if my node.write is not null, then return node.write. So I have to check if my node.left is null, that means I doesn't have any left child. I have to return node.write. If my node.write is null, then I have to return node.left. I hope you understood this approach very clearly, and thank you guys for watching this video. If you like this video, please do like button and subscribe our Pepcoding's YouTube channel. Thank you.